Hi everyone, this is another RF unit I bought from eBay. Very heavy unit. This is a metal cast. It's kind of like a carry carry suitcase kind of thing, but it's all made of metal. Very thick metal cast, very heavy unit, and I don't know if it's visible here. Let's just get the camera to focus properly. So we got 13 gigahertz X-MIT, and we got the receiver 12.8 gigahertz, and then you got all other bits and bobs there. So we got one RF connection here, and on this side we got 4 RF connection. So we got the cable A, cable B, and we've got AGC, which is automatic gain control A, and automatic gain control B. So I'm just gonna put this down and open sesame. Lots of RF goodness inside. So I have no idea what's going on. Under here we got the duplex filter, and you got space here. I don't think I can fit this all in my desk, but then you got a space here for a big massive antenna. So I don't know what this was used for, some form of military something. But then what we got here on the actual case, if I can show it to you before this falls off my desk. Here we go. We got a nice diagram of everything and the frequencies and everything there. So this is DMC-13M protected RF unit, whatever that means. And then we got a list of what each section is called, and the corresponding maybe options that you can see here. So you got option 001 for this and 2, and then you got 4 and then 001 for the rest of the stuff. But very nice unit. Oh, I just there we go. Very heavy, but this is made in USA. Sticker set on the side. But yeah, so what we got here, Digital Microwave Corporation, whoever they are. Lots and lots and lots of RF stuff in here. So I've been taking everything out one by one, but on the actual that plastic bit, it says that do not overturn the SMA connectors. You know, all these connectors that you have here, as you can see, they got these little red kind of plastic on them. So that's just to indicate, like, you know, how far you've turned these, and don't turn them anymore, or to lock them so you don't turn them anymore. But yeah, there's lots and lots of RF stuff in here to take apart. So we see a lot of circuitry here. I presume these might be DC-DC converters, maybe some form. Yep, DC-DC converter, it says there as well. And we got another DC-DC converter over here. So we got the input, and then we got the output there. So we got plus, and then you got ground, then you got minus, then you got minus, and then you got plus as well. And then we got some other circuitry here, and we got some circuit underneath this. So this is 2-layer. So we got the 2 boards on top of each other, and then we got a lot of test points over here with these little plasticky text point thing, and we got some on this side as well. But yeah, I'm gonna take time opening this, taking this apart, because I don't want to ruin anything. So I'm gonna do this really slow. But yeah, this was a really good find on eBay. And if you do search on eBay things like this, sometimes you get lucky and you find things like this. Right now I'm very intrigued with RF stuff, so I'm just bidding on anything that I find. This unit is really cold because it just literally got delivered to me now, and it's really cold here today. So this was in the van, presumably from the more early hours in the morning, so the unit is gone really cold. So let me get my small, there we go, there we are. So what does this say? Here we go, 310 megahertz bandpass filter. This is all soldered onto the actual board, this casing, so I can't really take it apart to see what's inside. But yep, oop, that's one thing out. We got another one over here, and it's exactly the same. So we got the same kind of thing, but I need to figure out how to take this thing apart. There we go. These metal cables, RF cables, they're not really going to be any use to me, because once you they're only good at the shape they are. So once you start bending them and you know, taking them out of the shape they are, that's going to affect their characteristics. So they're not really designed for kind of recycling, so reuse and stuff like that. So the normal ones, these are really good, so I do keep these ones. But the metal ones, I just got a bag full of them. I don't really use them for anything special. So we've got one over there. There we go. As you can see here, really good quality, but once you start taking them out of shape like so, we actually affect their frequency response and the rest of the jazz. So by me just bending it and straightening it, I'm sure I've changed its characteristics. But then you got very complicated unit. God knows what it's used for. If anyone knows, leave it in the comment what this is used for. But yeah, these ones, they're fine. I keep these. I got a lot of these. Nice high quality cables. It's just the camera focuses. There we go. There we are. I think I will need to take these out first, maybe. Yeah, I need my. There we go. There we are. Everything is tied down, so as I'm not using this anymore, I can just use my wire cutter, and then these can just get ungot like this. We need is a Phillip. Yep. Okay. There we go. So everything is screwed down to this aluminium plate at the bottom. So what we got here, this is connected to this via these metal shielded cables. So what we got here, there we are. If the camera focuses, there we go. So what this is, no idea, but it does have DC and then 9218, so presumably that's from DC to 9.2 gigahertz. It might be an isolator, it might be a filter, God knows, doesn't say on it what it is. So that's that. And then what we gotta do, take these parts. It's like you need to be a mechanic for these. Take these apart. There we are. Let's try to put as less force as possible on these. It's funny, these ones are mounted on a kind of like a rubbery kind of thing, so you can see they can shake, but unlike the other ones, like these ones, they don't have what these are, like kind of springy. So presumably this is because if this thing get knocked around or thrown onto the ground and stuff like that, this has a give on it so it doesn't come off or break, and they're not using any metal cable on these, so these can swing around without being damaged, unlike these ones. Okay, let's see. Let me see. Okay. There we go. We got the same thing again as we had with the other one. So this one is, again, says DC to 9218, and it comes with this cable, and you got this little funky looking connector. You can see. But yeah, I'm just going to grab my screwdriver. Let's see. Okay, I'll need a Philip one. Okay, now we need to take these apart, and this is connected to this unit over here. This unit over here is connected to this, and now we need a flat screwdriver. Get into this. There we go. Comes out here, and then this is connected all the way to here. So we need to get rid of this. There we go. Something is stuck somewhere. There we go. This cable is stuck here. Take these apart as well, because these are really rigid and hard. And there we go. yeah, we got the same thing of before. The camera zooms. There we go, focuses DC to 9218. So it might be isolators, I'm not 100% sure. But as you can see, we had two over here and we got two over there, and we had some going to different sections. We got over here again. So I will find out what they are later on and put it into the post. So here we go. This is one bit of the RF section. What we have here? The camera. Stupid camera focuses. There we go. So we got the Ferrocom, and then we got 12.5 to 13.5 gigahertz. Doesn't say what it is on it. And then we got this little unit over here. So we got RF in, RF out, and we got a little thing on top of it, but I'm not sure if this is actually, oh yep, it is controlling this via that little tiny connection you can see there. So presumably they're using the chassis for the ground, and then they've got the little thing poking out of there, which is controlled by this op amp. So we got LM2903. Oh, we can focus this. Stupid camera. There we go. So we got an op amp there, the national semi op amp, and then we got a trim pod there, and that is controlling something inside this little unit. Yeah, so we got RF in, RF out, and then we have this unit over here, which says up converter. So we got the local input, we got the filter, and we got the output there. And this is the filter, as you can see here. I had this on top of it. Now let me just disconnect the filter. Then we can take a good look at the filter, see what it is. There we go. Just put that down there. So you can see the filter how it is. Basically you got the RF coming in, I don't know, whichever it was, RF coming in, and then you got these screws, and presumably by putting these screws in and out, you are affecting the frequency. So basically you got the frequency coming in and going out of here, so there might be cavities inside here. So as the frequency is traveling through the cavities, with these screws coming in and out of it, affects the frequency. So I think that's how they are using this as a filter. And I had this kind of filtering with that 13 gig Nokia point-to-point link and voice unit that I took apart. They had a similar kind of filter on them. So yeah, at these frequencies they tend to use plumbing instead of normal filtering. And then we got this, which is as an up converter, and then you got the rest of the information on here, and then this got the voltages that comes in. So you got the local input, filter, and RF output, and then you got the 310 megahertz in ALM, and then you got plus 8.4 to test ground, and then to adjust detection voltage. So yeah, I'll just take that later on, take them apart individually, because right now they're all just stuck together. Okay, how is this little thing gonna come out? Let's just take this out first. There we go. Same thing again, DC to 9218. Now this is held in by these screws. Like so, and then we got a little pin that goes into here. We got the warranty void if sealed broken on this, and we got I presume the voltage going into here, and we got two connectors. We got another connector there. Oh, there we go. This is what it says. Synthesized local oscillator. That's it. Doesn't say the frequency, or maybe it does. Maybe that is a code for the frequency. No idea. But yeah, so this is the oscillator. And this little, you can see like with the screws. I take a lot of military stuff apart, and I recognize these screws the way their heads is. If the camera focuses on this thing. Nope, I definitely need to get a better camera than this. Stupid camera doesn't like to focus. There we go. Yeah, these screws are the type of screws that military use. You can see how the shape of the head is. Anyway, enough of the screws. Let's get to the good bit. But yeah, this is a local oscillator. I'm not sure about the frequency, but we will find out later once I might tear this down further a little bit. Just take this top a bit and see what's inside. But yeah, we got some voltage going out, and some filtering right at the input voltage. But yeah, warranty void if still broken. We had there, and this was where the thing was connected on top. And let's just take it apart and let's see what makes it so bouncy, like so. Okay, so we got this just metal plate, aluminium plate, and then we had these. So again, that is sitting on top of another block of aluminium, and I don't think that comes off. It should come off. I've unscrewed it. Seems something. No, it's not connected to anything from the bottom. I don't want to damage this. I want to connect this to the actual unit. But yeah, we deal with that later on. But that is connected to something over here, which is you can see it moves this way, but it is connected to something at the bottom. I've unscrewed both of the screws here, but it's still connected to there. Not a problem, we deal with that later. Let's get to the good bits. Just take that apart. Okay, now I know how to get this off, because this whole block, which is connected to this aluminium chassis at the bottom. When it comes out, it probably got a screw connected at the back side, so we can take that apart. Let's take this off. And what this is, let's see, there we go, got down converter, RF in, RF out, and the down converter 576 megahertz. Got RCVR, allow input, and we got the detection voltage, and then we got the automatic gain control, and we got ground and 8.4 volt. And this is connected to this metal bed, and we got something going out that side, and that's it. On this one there's no filtering like how it was on the other one. There's no filtering on the power connection, but I'm 100% sure they know what they're doing. Okay, that's another thing. Put this aside. Okay, now let's take this apart. They seem to be using an odd voltage here, 8.4. And like, you know, where would you get an 8.4 voltage regulator? Okay, I think it's connected. Yeah, connected via PCB headers. Let's just take this apart. Even these little yellow RF cables are very rigid and hard to move around. Don't want to break them, so let's just, there we go. Yeah, this PCB was connected via these pin header interconnects to the one at the bottom there. This probably is the power supply board, and some other boards. So we've got the little LEDs, status LED here. So we've got the power on, which is the green. Help if the stupid camera focuses. Yeah, there we go. Then we got the RF assembly alarm. Then we got the local oscillator alarm, and then we got a whole lot of other LEDs here for different alarm sections. And then we got every connector is nicely named, so you know what it's what. So over here we got the 7805 voltage regulator for 5 volt, and then we got another voltage regulator just standing up, and that is 7905. So to get the -9 volt, sorry, -5 volt, and then we got some BNC connector over here standing up for some form of test point, and over here we got the back of it, and this is our massive voltage regulator, sorry, DC-DC converter. Calyx, never heard of them. There we go, got date code, July 1993. So yeah, Digital Microwave Corporation, 3 amp. Oh, look, there we go. That's how we get the 8 volt out. 30 to 60 DC input, 8 volt DC out at 3 amps. So this is where we get our 8.4 volt out with the DC-DC converter. Anyway, that goes there. This generally is held via these, which are acting not only as a screw to hold it down, but as a spacers for the PCB on top. There we go. Oh, there's one missed one. There we go. Get rid of that. And we got another board over here. these cables, and they can go there. So what we got over here, we got a crystal oscillator, which is marked at 7.3, or is it 37 megahertz? I believe this might be 37 megahertz. And if it shows properly on the camera. Oh, my camera is a bit rubbish. Oh no, doesn't show. Anyway, it's either, yeah, I think it is 37 megahertz. Then we got some logic, and we got some yeah, we got some logic over there. We got some op amps, and I don't know what is under this, but this is all soldered, soldered in an actual PCB. And then what we got here, we got the Motorola op amps. We got the 1350p, and we got the LM258. I think LM258 might be a voltage reference. I'm not 100% sure, but sounds kind of familiar. And we got another LM258 over here, and another LM258 over there. And I believe this might be a PAL or a GAL. Let's just take it apart. Yep, Altera. Yeah, well, Altera probably. Let's see. Let's just get my. If I can find it. It was somewhere here before. Seem to lost it now. Let's just use our nails to see what is under this. So it doesn't say, but it's either a PAL or a GAL. And this is the back of the unit. Okay, now I see what is underneath this. If you look at here, I'll get down here. It's got these little RF transistors at the bottom here. So this inside here must be some form of amplifier or some form of oscillator or something. It's using high output RF transistors. So that's that. You can put that aside now. And then we got these screws. Yep, this is just one section over there. So we can just unscrew it over here.